Alright, welcome to section 12.3, Nonlinear Systems of Equations. Alright, so main thing to note here is we're working with systems. So once again, that's when we have more than one equation we're working with. And then these systems are nonlinear, which means they aren't lines. They're any of the other ones we have seen. So one other thing to note is we won't be graphing some of the nonlinear equations. We'll graph a few of them, but none of the hard ones. So the ones that we have graphed in this course are lines aren't nonlinear. The nonlinear ones we have graphed are parabolas, circles, and that's basically it, just parabolas and circles. So those are the only ones you'll be graphing. Any of the other equation types that are not parabolas, circles, or lines, you will not be graphing those in this course. Alright, so first off, hint. If the system has the same type of equation, okay, so same type, for example, if they're both circles, they're both parabolas, or they just look the same, and this is when I'm talking about the variables, and you need to look at the power on the variables too, then we're going to use elimination to solve. Now, if the system has different type of equations, so they're different, once again talking about variables and the power on the equations, or the variables, then we're going to use substitution. And the plan for this is sub the lower into the higher. And that's what I'm talking about powers. Once again, when I'm talking about powers, I'm talking about, for example, if I look at x squared, the power I'm talking about is the square. Alright, let's take a look at this system we have here. So once again, one thing to notice, a system is sort of, you can visibly tell something is a system by that little bracket there. So on your work, and this is something I did do on exams, I will grade for that. Make sure if you're working with a system, you use those little braces. So what do we have here? Let's see, the first equation is, we have an x squared and a y squared. What has an x squared and a y squared? This is a circle. The number in front of the x and the y is the same, so this here is a circle. And the bottom one is, we just have x to the 1 power, y to the 1 power. The bottom is linear. Now you might say, hey wait, I thought we were doing nonlinear. Well, one linear equation can be in the system, but the concept is one of them is not linear, which would be our circle one right there. Okay, so how would we solve this? Well, since they're not the same, we're going to use substitution. That's the plan. And we're going to sum the lower one into the higher one. So we're going to go ahead and solve. Let's just go ahead and solve for y on the bottom one. So I'll rewrite my original equation, the linear one. Subtract 2x from both sides. Negative y equals negative 2x plus 3. Divide by negative 1 on all sides. I get y equals 2x minus 3. So with this, I'm going to go ahead and sub. So sub into my circular equation. So this says that y equals 2x minus 3. So we'll replace y with 2x minus 3. Alright, and then let's see. So we have x squared equals, and we have this binomial. So once again, be careful with the binomials. We can't just distribute that 2 in. So it's going to be x squared plus 4x squared, so that's it inside, minus 6x minus 6x plus 9 equals 9. Okay, so the 9s are going to cancel each other out. And we are left with 5x squared minus 12x equals 0. Let's see, how can we solve this? Well, let's go ahead and factor an x out, and we get 5x minus 12 equals 0. And then, okay, zero factor property, set each factor to 0, and please note, this is an important part. Some students I've noticed will stop at this step and then go directly to your answer without letting our factoring equal 0. So I look to make sure that you set your factoring equal to 0, and I also look to make sure that you did this step right there. Okay, so just keep that in mind. So x equals 0 is one option, and then solving for x on the other side. Add 12 to both sides, we get 5x equals 12. then divide by 5, divide by 5. So x equals 12 divided by 5. Alright, so we have two options for x. Are we done? No, we're not done quite yet. We still have to solve for y. So let's go ahead and write solve for y, and I'm going to write with what? With, I'll just use this down slash for that, x equals 0. So one thing to note, especially for solving with systems, please label things. Don't write an equation directly below this, because it looks like they're connected. Okay, so since that is not directly connected to what we're doing down here, I'm going to write them a label and then continue working. So always label, especially if there's not a ton of room. Alright, so let's solve for y. So y is going to equal 2 times, and our new input is going to be 0. Once again, we got this equation from when we solved for y originally. And then y is going to equal -3. So that's going to be one of my answers. 0, -3. And what else? So we're going to solve for y with x equals 12 over 5. Kind of a weird one. Okay, so y is going to equal 2 times -3. So 12 over 5 is our new input. Nothing cancels there, so we're left with y equals. So 2 times 12 is going to be 24 over 5. Now I want to add the fractions, so I'll go ahead and put a 1 under the 3, and then I'll build up by multiplying by 5. And I have y equals 24 over 5 minus 15 over 5. So what is 24 minus 15? That's going to be 9. So y is going to equal 9 over 5. And then the other answer is going to be, let's see, it was 12 over 5, 9 over 5. And you don't need to make it any more complicated than that. You don't need to give me the decimals, as long as the fraction is the simplified version of the fraction. So you might be a little confused. How come we have 2 answers this time instead of 1? Because usually we'd have 1 or something like that. Well, not usually. But let's think for a second. What kind of equations did we have here? We had a circle, remember? A circle. And then we had a line. So what options do we have for a circle and a line intersecting? Well, one option is the line doesn't cross the circle at all. What's another option? Well, maybe the line crosses the circle, boop, once at one point, so we'd have one solution, x, y. Or the line can cross the circle at 2 points. And in our case, the line crossed the circle at 2 points. Okay, so once again, these are the possible solutions we could have. No solution, one solution, or 2 solutions, x, y, x, y. Okay, and so you might say, how come we didn't substitute our x value back into the circle instead of into the linear equation? Well, because the circular equation has that square, we would have to be working out to figure out which answers are extraneous. So that's why we're going to sub back into the linear one. It doesn't have the square, we don't have to work out which answers might be extraneous. Alright, so just keep that in mind as well. So let's take a look at the next example. Solve the following. So what kind of equations do we have here? We have, well, this is a circle, because the x and the y are both squared, and they both have the same number in front. Now the bottom one, it might look like a circle because we have an x squared and a y squared. However, the x has a 4 and the y has a 13. So the bottom one is not a circle. It's another type of shape, which you'll learn if you go on to Math 135. However, they follow the similar concept that we have an x squared and then we have a y squared. So since these guys are similar equations, we're going to go ahead and use elimination. So let's use elimination, and when we're solving with elimination, we're going to continue using our braces, so please make sure to do that in your own work. That is something I grade for. It just helps to keep your work neat. Okay, so what are we looking to do? Well, in order to eliminate, we need to match one of the variables. I'm going to choose to match the x's because to match the y's, we'd need to have a 13. The x's just needs a 4, so that's easier. So I'm going to go ahead and multiply the top equation by 4 on both sides. And then I get 4x squared plus 4y squared equals, and I'm just going to leave it as 4 times 16. Alright, and now let's see, should I add or subtract? Well, if I subtract, well, let's say, if I added, I would end up with an 8x squared. And my goal was to cancel the x's, so that's not going to work. So I'm going to go ahead and subtract, and once again, this is important that you show me which symbol you chose to use. Okay, so please make sure to show that in your own work as well when you're doing your exam. I chose a minus sign. So when I subtract, those guys are gone. Then we have 4y squared minus 13y squared. So that's going to end up being 9y squared equals, and then let's see, so 4 times 16, let's multiply that out. It's going to be 64, and then we have 64 minus 100. So that'll be 36. All right, and then let's keep solving. So divide by 9, and we have y squared equals, so 36 divided by 9. That's going to be 4. We're almost done. Okay, so square root both sides to get rid of that square. And we have y equals plus or minus the square root of 4. So y is going to equal plus or minus 2. So there are two possibilities for y. And now let's see. How do we solve for x? Which one should we choose? Well, they both are squared. So each equation has the x squared and the y squared. So it doesn't matter which one we choose. I'm going to choose the top one because it just has simpler numbers. Okay, so let's go ahead. X squared, y squared, 16. I'm going to go solve for x when y is equal to, once again we have two answers, the negative, or the positive and the negative. Let's go ahead with the positive 2. Okay, so x squared plus, we're substituting positive 2 for y. And so x squared plus 4 equals 16. Minus 4 from both sides. X squared is going to equal 12. Squared in both sides, so this is not as pretty. Oh, remember that plus or minus, very important. Let me highlight that. And we get that x equals plus or minus the square root of 12, which we can simplify to plus or minus the square root of, well, we know that 12 is root 4 times root 3, so that'll be 2 root 3. 2 root 3. Okay, so those are two possibilities. Ooh, getting a lot of possibilities here. And then one more. Solve for x when y is equal to, which one did we not do? We have to do the negative, negative 2. So if x squared plus y squared equals, what was it, 16. This time we're substituting in a negative 2. It actually looks like it doesn't make much of a difference because we square it. So it'll be a positive 4. 16 minusing 4 from both sides. Square root both sides. And we get x equals plus or minus 2 root 3. And once again, we showed how to do that earlier up here to get 2 root 3. So interesting. Let's take a look at what answers we have. We had when y was positive 2, we ended up with two answers. 2 root 3 and negative 2 root 3. So negative 2 root 3 and positive 2 root 3. And then we had another option. When y was negative 2, we had two answers again. So 2 root 3 and negative 2 root 3. Now, none of these answers are actually the same, so we have to write them all out. Now, would this make sense? How can we have 4 possible solutions? We're talking about just two equations. How do we get 4 possible solutions? Well, let's go ahead and draw out what these might look like. So the first equation, we know that that is a circle, right? A nice perfect circle, which I'm really not drawing. Now, the bottom equation, because the number in front of the x and the number in front of the y are different, but we still have a plus sign, this is what we would consider an ellipse. So think of a circle and then you squish the circle a little bit. It's an ellipse. Now, does it make sense that we could have 4 possible solutions? It does, because my ellipse would intersect my circle at 4 points. That's possible. Or, for example, you could have the ellipse intersect the circle only 2 points, 1, 2. Or it's possible to have the ellipse intersect the circle once, boop. Or, even more possible, for the ellipse and the circle to never intersect. So we actually have 4 possibilities. Okay, but remember, you don't need to know what an ellipse is for this course. That's just a visual to let you know why we have 4 answers. All right, let's see what else we have. Ooh, okay, so we have example 3. Solve the following. Let's see, what kind of equations do we have here? You might be tempted to say the top one is linear because they have the x and the y, each have a 1 power. But remember, they're being multiplied together, so what is their power, actually? We just take the two of their powers, add them together, and we get 2. So that has a power of 2, and the bottom one, is that linear? What is that? Yeah, the bottom one is linear. So we have a linear and a nonlinear. They're not the same type of equation, because one has an x times a y, and the other one has an x, and then we have the plus y. So, because they're not the same, what are we going to use? We're going to use substitution, and we're going to sub the smaller one into the bigger one, which basically means this is the smaller because it has powers of 1, into the bigger because that has the squared power. That's sort of quotation because it's technically not a square, but we still consider it to the second power. So let's go ahead and do that. So I'm going to write solve for, what should we solve for? Why not y? I just tend to do that as a tendency. You could always solve for x if you want to. So let's see, we get y equals 3 minus 2x. Actually, we write that, negative 2x plus 3. Alright, so now let's go ahead and sub. So we're going to sub, what do we have? Well, y is equal to negative 2x plus 3. So we're going to replace that with negative 2x plus 3. And we have x times negative 2x plus 3 equals negative 5. It's multiplication, so let's go ahead and distribute. And we get negative 2x squared plus 3x equals negative 5. Ooh, this is quadratic. So it's quadratic. To solve this, we're going to go ahead and add 5 to both sides. Set this equal to 0 to solve. I don't like solving when the x squared is negative, so let's go ahead and multiply everything by negative 1. You could also divide by negative 1 if you wanted to. Alright, can we factor this? Yes, we can factor it. So we can factor it into x plus 1, 2x minus 5 equals 0. Set each factor to 0. Once again, an important step. Please make sure to do this. And then let's solve. So subtract 1, x equals negative 1 is one option. What's the next one? Add 5 to both sides, and then we have 2x equals 5, divide both sides by 2, and we get x equals 5 over 2. Okay, so we had two options, but we only just solved for the x. So let's go ahead and solve for y. So we're going to solve for y. When x equals, we have two options. We have 5 over 2 and negative 1. So let's go ahead with negative 1 first. So y equals negative 2 times what? Plus 3. Once again, remember we get that equation from above. So plugging in negative 1 for x, y equals 2 plus 3, y equals 5. So that's the other option we have, or the other answer. So answer, let me change that. Answer, we have negative 1, 5. And it looks like we're going to have one more when x is equal to 5 over 2. So let's go ahead and solve y when x equals 5 over 2. Y equals negative 2 times what? Plus 3. Plugging in 5 over 2. Ooh, the 2's cancel each other out. That's nice. So then y equals negative 1 times 5 plus 3. So y equals negative 5 plus 3, which means y equals negative 2. Alright, so we had these two answers. So 5 over 2 and negative 2. Does this make sense? Well, let's take a look. So, you may or may not have noticed, but this equation above is actually a rational equation. Because if I divided both sides by by x, we would get y equals negative 5 over x, which is a rational equation. We've graphed these before, right? They look something like this, and then they have an asymptote or something. And the other equation we had was a line. So for our problem, our line crosses our rational equation in two places, which is why we get those 2 points. And once again, there are other options. We're not going to really go into that too much because it's not super important, but you can make up that there are a few other options. My line can either not cross the asymptote or the rational equation at all, or it could possibly just cross once. So for example, this is not at all crossing, or this would be crossing once. Okay, so possibility is no solution, one solution, or two. But we can't have four solutions for this equation. But you can if you have circles and ellipses, for example. So a great way to know how many possible solutions you could have before you even start solving is to think about what kind of equations you're looking at. Figure out what they would look like graphically, and that gives you a great idea on what kind of equations, the number of answers you're looking for. Alright, that is it for this section. If you have any questions, once again, please come to my office hour, or send me an email and I'll be glad to help you out with either the lecture notes, the lecture video, or the homework.